NFPA 99, the standard for healthcare facilities, mandates specific requirements for electrical wiring in healthcare environments to ensure patient safety and minimize the risk of electrical hazards. When it comes to lighting circuits operating on normal power within healthcare facilities, there are restrictions on the type of metal-clad cable, or MC cable, that can be used. Standard type MC cable, which does not have the HCF designation, is not permitted for these applications. The reason for this restriction lies in the enhanced safety features that HCF designated MC cable provides. HCF cable is specifically designed and tested to meet the stringent requirements of healthcare facilities, offering increased protection against electrical noise, grounding issues, and other potential hazards that can compromise sensitive medical equipment and patient well-being. The HCF designation signifies that the cable has undergone rigorous testing and meets specific performance criteria related to shielding, grounding, and insulation integrity. These enhanced features are crucial in healthcare environments where electrical interference can disrupt the operation of life support systems, monitoring devices, and other critical medical equipment. By requiring the use of HCF-designated MC cable for lighting circuits, NFPA 99 aims to minimize the risk of electrical disturbances that could potentially endanger patients. It is important to note that the restriction on standard type MC cable applies specifically to lighting circuits on normal power in healthcare facilities. Other types of circuits, such as those powering non-medical equipment or emergency systems, may have different requirements depending on the specific application and the applicable codes and standards. Therefore, it is essential to consult the relevant sections of NFPA 99 and other applicable codes to determine the appropriate wiring methods for each type of circuit in a healthcare facility. Failure to comply with the requirements of NFPA 99 can have serious consequences, including fines, legal liabilities, and, most importantly, increased risk of electrical hazards that could endanger patients and staff. Therefore, it is crucial for electrical contractors, engineers, and facility managers to be fully aware of the restrictions on MC cable usage in healthcare facilities and to ensure that all wiring installations comply with the applicable codes and standards. In summary, NFPA 99 requires the use of type MC cable with an HCF designation for lighting circuits on normal power in healthcare facilities. Standard type MC cable without the HCF designation is not permitted due to its lack of enhanced safety features. Compliance with this requirement is essential to ensure patient safety and minimize the risk of electrical hazards in healthcare environments. When planning electrical installations in healthcare facilities, it is important to consult NFPA 99 and other applicable codes to determine the specific requirements for each type of circuit. By adhering to these requirements, you can help create a safer and more reliable electrical system that supports the delivery of quality healthcare services. Firstly, understand the purpose of NFPA 99. It serves as a comprehensive set of guidelines and requirements for electrical systems in healthcare facilities. Its primary goal is to minimize the risk of electrical hazards that could potentially harm patients, staff, and visitors. Secondly, recognize the importance of HCF-designated MC cable. This specialized type of cable is specifically designed and tested to meet the unique demands of healthcare environments. It offers enhanced shielding, grounding, and insulation properties, which are crucial for preventing electrical interference and ensuring the reliable operation of sensitive medical equipment. Thirdly, be aware of the specific restrictions on standard type MC cable. This type of cable, which lacks the HCF designation, is not permitted for lighting circuits on normal power in healthcare facilities. This restriction is in place to minimize the risk of electrical disturbances that could compromise patient safety. Fourthly, understand the implications of non-compliance. Failure to adhere to the requirements of NFPA 99 can result in serious consequences, including fines, legal liabilities, and increased risk of electrical hazards. Therefore, it is crucial to ensure that all electrical installations in healthcare facilities comply with the applicable codes and standards. Fifthly, consult with qualified professionals. The electrical contractors, engineers, and facility managers should have a thorough understanding of NFPA 99 and its requirements. They can provide expert guidance on selecting the appropriate wiring methods and ensuring compliance with all applicable codes and standards. Sixthly, prioritize patient safety. The ultimate goal of NFPA 99 is to protect patients from electrical hazards. By adhering to the requirements of this standard, you can help create a safer and more reliable healthcare environment. Seventhly, stay updated on the latest codes and standards. Electrical codes and standards are constantly evolving to reflect advancements in technology and changes in industry best practices. It is important to stay informed about the latest updates to NFPA 99 and other applicable codes to ensure that your electrical installations are always up to code. Eighthly, consider the specific needs of the healthcare facility. Different healthcare facilities may have different electrical requirements depending on the types of medical equipment they use and the services they provide. It is important to consider these specific needs when designing and installing electrical systems in healthcare facilities. Ninthly, implement a comprehensive electrical safety program. In addition to complying with NFPA 99, healthcare facilities should implement a comprehensive electrical safety program that includes regular inspections, testing, and maintenance of electrical equipment. This program should also include training for staff on electrical safety procedures. Tenthly, document all electrical work. It is important to document all electrical work performed in healthcare facilities, including the types of materials used, the methods of installation, and the results of any testing or inspections. This documentation can be helpful for troubleshooting electrical problems and ensuring compliance with codes and standards. MC cable, or metal-clad cable, is a factory assembly of one or more insulated conductors enclosed in a metallic sheath. It is commonly used in electrical wiring for both residential and commercial buildings due to its durability, flexibility, and ease of installation. However, when it comes to healthcare facilities, the use of MC cable is subject to specific restrictions outlined in NFPA 99, the standard for healthcare facilities. One of the key restrictions is that standard type MC cable, which does not have the HCF designation, is not permitted for lighting circuits on normal power in healthcare facilities. This restriction is in place to ensure that the electrical system in healthcare facilities is designed and installed to minimize the risk of electrical hazards that could potentially harm patients, staff, and visitors. HCF-designated MC cable offers enhanced safety features compared to standard type MC cable. These features include improved shielding to reduce electromagnetic interference, enhanced grounding to minimize the risk of electrical shock, and more robust insulation to prevent short circuits and other electrical faults. In healthcare facilities, where sensitive medical equipment is used to diagnose and treat patients, it is crucial to minimize the risk of electrical interference. Electromagnetic interference can disrupt the operation of medical equipment, leading to inaccurate readings, malfunctions, or even equipment failure. HCF-designated MC cable helps to reduce electromagnetic interference by providing a more effective shield against external noise. In addition to reducing electromagnetic interference, HCF-designated MC cable also provides enhanced grounding. A proper grounding system is essential for preventing electrical shock in healthcare facilities. If a fault occurs in an electrical circuit, a properly grounded system will provide a low-resistance path for the fault current to flow back to the source, tripping the circuit breaker and preventing a dangerous voltage from appearing on exposed metal surfaces. HCF-designated MC cable has a more robust grounding system than standard type MC cable, which helps to ensure that the grounding system in the healthcare facility is effective in protecting patients and staff from electrical shock. Furthermore, HCF-designated MC cable has more robust insulation than standard type MC cable. The insulation on electrical wires is designed to prevent short circuits and other electrical faults. In healthcare facilities, where electrical equipment is often used in close proximity to patients, it is crucial to have a high level of insulation protection to minimize the risk of electrical hazards. HCF-designated MC cable has thicker and more durable insulation than standard type MC cable, which helps to prevent electrical faults and ensure the safe operation of electrical equipment in healthcare facilities. It is important to note that the restriction on standard type MC cable applies specifically to lighting circuits on normal power in healthcare facilities. Other types of circuits, such as those powering non-medical equipment or emergency systems, may have different requirements depending on the specific application and the applicable codes and standards. Therefore, it is essential to consult the relevant sections of NFPA 99 and other applicable codes to determine the appropriate wiring methods for each type of circuit in a healthcare facility. In addition to the restriction on standard type NC cable, NFPA 99 also includes other requirements for electrical wiring in healthcare facilities. These requirements cover a wide range of topics, including grounding, bonding, overcurrent protection, and emergency power systems. Compliance with these requirements is essential to ensure that the electrical system in healthcare facilities is safe and reliable. Electrical contractors, engineers, and facility managers who work on electrical systems in healthcare facilities should be thoroughly familiar with NFPA 99 and other applicable codes and standards. They should also have the necessary training and experience to design, install, and maintain electrical systems that meet the stringent requirements of healthcare environment. Failure to comply with the requirements of NFPA 99 can have serious consequences, including fines, legal liabilities, and, most importantly, increased risk of electrical hazards that could endanger patients and staff. Therefore, it is crucial to take all necessary steps to ensure that electrical systems in healthcare facilities are designed, installed, and maintained in accordance with the applicable codes and standards. The NEC, or National Electrical Code, also plays a significant role in electrical installations, but NFPA 99 has specific modifications and additions for healthcare settings. For example, NEC Section 517.13 requires that the grounding system in patient care areas shall be installed in accordance with NEC Section 250.146. This means that the grounding system must be designed to minimize the risk of electrical shock to patients. The HCF designation on MC cable indicates that the cable meets specific requirements for use in healthcare facilities, including enhanced shielding and grounding capabilities. These enhanced features are crucial for minimizing electrical noise and ensuring the reliable operation of sensitive medical equipment. The NEC provides general guidelines for electrical installations, while NFPA 99 provides specific requirements for healthcare facilities. In some cases, the requirements of NFPA 99 may be more stringent than those of the NEC. For example, NFPA 99 may require the use of HCF-designated MC cable in situations where the NEC would allow the use of standard type MC cable. It is important to understand the differences between the NEC and NFPA 99 and to comply with the more stringent requirements when working on electrical systems in healthcare facilities. In addition to the requirements for MC cable, NFPA 99 also includes requirements for other types of wiring methods such as conduit and cable tray. The specific requirements for each type of wiring method will depend on the application and the location within the healthcare facility. For example, wiring in patient care areas may be subject to more stringent requirements than wiring in administrative areas. It is important to consult the relevant sections of NFPA 99 and other applicable codes to determine the appropriate wiring methods for each type of circuit in a healthcare facility. When selecting electrical equipment for use in healthcare facilities, it is important to choose equipment that is listed and labeled for the intended use. Listed equipment has been tested by a third-party testing laboratory and found to meet the applicable safety standards. Labeled equipment has been marked with the name of the testing laboratory and other information to indicate that it has been listed. Using listed and labeled equipment helps to ensure that the electrical system in the healthcare facility is safe and reliable. In addition to selecting the appropriate wiring methods and electrical equipment, it is also important to install the electrical system in accordance with the manufacturer's instructions and the applicable codes and standards. Improper installation can lead to electrical hazards such as short circuits, ground faults, and electrical shock. Electrical contractors who work on electrical systems in healthcare facilities should be properly trained and experienced in the installation of electrical equipment and wiring methods. They should also be familiar with the requirements of NFPA 99 and other applicable codes and standards. Regular inspections and testing of electrical systems in healthcare facilities are essential to ensure that the systems are operating safely and reliably. Inspections should be performed by qualified electrical inspectors who are familiar with the requirements of NFPA 99 and other applicable codes and standards. Testing should be performed using calibrated test equipment to verify that the electrical system is functioning properly. Any deficiencies identified during inspections or testing should be corrected promptly to prevent electrical hazards. Healthcare facilities should also have a written electrical safety program that includes procedures for identifying and addressing electrical hazards. The electrical safety program should be reviewed and updated regularly to ensure that it is effective in protecting patients and staff from electrical hazards. Training on electrical safety procedures should be provided to all employees who work with or around electrical equipment. In summary, electrical systems in healthcare facilities are subject to stringent requirements to ensure patient safety and minimize the risk of electrical hazards. NFPA 99, the standard for healthcare facilities, provides specific guidelines for electrical wiring, grounding, overcurrent protection, and emergency power systems. Compliance with these requirements is essential for all electrical contractors, engineers, and facility managers who work on electrical systems in healthcare facilities. By following the requirements of NFPA 99 and other applicable codes and standards, you can help to create a safer and more reliable electrical system that supports the delivery of quality healthcare services.